Hey mathematicians, it's time to grab your graphing calculators because we are going to be talking about scatterplots and best fit lines. You will need your graphing calculator later in this lesson, so find that, get the notes or a notebook, and let's get started. So we're going to use the example of we had an earthquake in 2004 in Parkfield, California, and they were measuring the intensity of the earthquake as we got further away from Parkfield in these 15 different cities. So we've got the 15 different cities, and we've got the intensity that they felt. If you don't know Roman numerals, IV is 4, V is 5, 1, 5, 1, 4. Let's get these down. That's a 3. I hope you know Roman numerals, but I've learned not to assume anything. And we are going to graph, the distance from the epicenter, and we're going to compare it to the intensity. So on the next slide, intensity is going to be our x, and distance is going to be our y. So we are going to graph these by going left and right to their intensity, and then up to the distance away from the epicenter. So the first one was Armona. It was an intensity of 4 and 89 miles away. So we go over to 4, up to 89. This is an estimate. And then we're going to do all of the other ones the same way. So if it was me, I would pause the video, I would graph the other dots, and then I'm going to graph them in the middle of the pause too. So your graph should look something like this. I used yellow when the dots were going to be really close to each other, so you could tell that there were two different dots there. And yeah, they're a little smudgy, but you get the picture. So our first question is, when drawing a line of best fit, what's one thing we must be sure to do? And the answer to this question is make sure an equal or roughly equal number of points are on each side of the line. This is an estimate. It's not a perfect guess, but we're trying to do the best we can with what we got. So let's go ahead and let's figure out where we're going to put our line of best fit. So I've got a clear pattern through here somewhere. That's not my line of best fit. I'm going to mess with that in a second. I just wanted you to see about where it should be, except I've got too many under it and not enough above it. I've got 3, 4, 5, 6 above it. It's really close. We're probably going to tilt it just a little bit. So I'm going to do that real quick and pause, and then we'll see how well yours matches up with what I've got. And the line I've got here is not perfect. I've got 8 on one side of it. I've got 7 on the other side. Yours might have tilted a little differently, but we're going to use this one as we move forward into the rest of the problem. So we've drawn in our line of best fit, and now we're being asked to describe the correlation. And one of the ways that we know how to describe a correlation is by talking about the slope. And we know that when a slope looks like this is a negative slope. So intensity and distance from the epicenter are negatively correlated. The idea is I can predict if it was further away, I could predict that it would be less intense. Or if it was more intense, I could predict that they would be closer to the epicenter. Negative correlation is like when one goes up, the other goes down. When one goes down, the other goes up. That's the idea of a negative correlation. It would be the other way around if it was positively correlated. Positive correlation, when one goes up, the other goes up. When one goes down, the other goes down. So we are doing a complete estimate. Again, we're doing this all by hand right now. We're not using a calculator. So we're going to estimate the line of best fit just based on how we drew it. So if I was using y equals mx plus b, I would need the intercept. I would need the slope. So if I look here, my intercept looks to be 1600. And if I look between these 2 points, as I go down 200, I go right 1/2, which means as I go down 400, I go right 1. So negative 400 over 1 is negative 400x. And that should be our slope. Again, this is our best estimate right now. It is not perfect in any way whatsoever, and we're going to use technology to calculate this here in a few minutes. So we're going to get a more precise line of best fit here in a minute. So now I'm going to ask you to pause this video, go to another tab, open up the video showing you how to do this on your calculator. You're going to need to type all of the data points into the lists in your calculator. The video is going to go over exactly how to do that. But just so you know, there is another video telling you how to do this in a graphing calculator. Just make sure that you watch that, or this is going to make no sense to you whatsoever. So now that you've watched that video, which you definitely pause and watch that video, and if you haven't, I'm going to say it again, you must pause and you'll watch that video. You're going to put your data into lists by going to Stat, then Edit, then put the data into L1 and L2. Intensity was our X value, so that's going in L1. And distance was our Y value, that's going into L2. Make sure you have all 15 data points put in. Then we are going to go to Stat, then Calc, then For, which should say linreg ax plus b, and it's going to pop us out with a line equation, excuse me. And if you do that, you're going to get y equals ax plus b, where a is negative 335.7 with 3 repeating, so we're just going to round to 0.7. X plus 1603.6. And you'll notice that our slope estimate was a little off, but our y-intercept estimate was great. So again, you're estimating, right? That's when you're doing it by hand, it's a complete estimate. When we are doing it by our calculators, we're going to get the exact right answer. And I implore you to watch that video where the video walked you through all of these steps instead of you listening to me talk about it right here. The video will show you every single one of those steps on the calculator. So now we're being asked to predict the intensity in Phoenix, Arizona, 918 kilometers away. So what we're going to be doing is we're going to be plugging in 918 for y, because x was our intensity. So 918 equals negative 335.7 x plus 1603.6. We're going to subtract 1603.6. Okay, and when I do that, let me type in my calculator real quick. We get negative 685.6. And then we're going to divide by negative 335.7. And we're going to get about 2.04, and we measure intensities in whole numbers, so it is roughly an intensity of 2. which they would list as a Roman numeral. And you can put that in your blank. Now we're going to describe the correlation of this data, and we're just going to do that in a little more detail than we did before. The correlation is negative as intensity increases, distance away decreases, so it's closer. As intensity decreases, so it's not as bad. Distance away increases, it's further away. Again, that's just a more thorough description of the correlation because we already described it as negative before. And then we need to make a prediction on who would be more expensive to insure, whether it would be in Los Angeles or in San Francisco. And this is where you're going to need to think for a minute. So I would implore you to pause and think and make a prediction before we talk about this together. So I hope that you thought, okay, what do I need to know? And you should have used your big brain and said, okay, I need to know which place is closer. And you would have looked up. Los Angeles is 196.7 miles away. San Francisco is 218.5 miles away. Now that's not perfect because I believe that those are road miles and not direct miles. But regardless, you would still expect it would be more expensive to insure a place closer to Parkfield. So, Los Angeles is closer. So, the earthquakes would be felt more intensely, making them more expensive to insure. That's how we'd figure something like that out. We needed new information about how far away they were. Los Angeles is closer, thus it's more expensive to insure. And that's it for this video. We are done with lesson 2.6. Remember, if you never watched the calculator video or you don't have a calculator, 1, you need to rent one as soon as possible, and 2, make sure that you watch the video so you know how to put this into your calculator because you will be required to on your assignment tonight. Good luck, and as always, message us if you have any questions at all.